Hey everyone, hope you all had a good weekend. Enjoyed the awesome weather that we had this weekend. We're going to be working with angle relationships today. We're going to do a proof at the end of class on an angle proof, a two-column angle proof. And then tomorrow we're going to do a lot of angle proofs in class, two-column ones. We'll bring back some line segment ones just to refresh our memory on those and keep going on that. Because like I say, it's practice makes perfect. Well, not practice makes perfect, but practice on proofs is what we're looking to do. The more proofs we can do, the better off we're going to be, and the better off we're going to be, the better we're going to get at doing them, which will help us down the road. I'm going to start today with a warm up. Take a few minutes here to kind of go through the questions, and then I'm going to have you enter your answers into Edpuzzle for both number twos before you move on. So take a few minutes to do that. Okay, warm up. Underline the hypothesis and circle the conclusion for each conditional statement. Number one, if an obtuse angle is obtuse, then it measures more than 90 degrees. So our hypothesis is the first part of the sentence. Our conclusion is that it measures more than 90 degrees. If a triangle is scalene, then it has three different side lengths. That is the hypothesis, the triangle being scalene. And then our conclusion is it has three different side lengths. For the second section, we were identifying whether the statement was true or false. If it was false, we were providing a counterexample. Then we were looking to write the converse of our statement, and then we were trying to identify whether the converse was true or false, and if that was false, we needed to provide a counterexample. So our first one, if two angles are linear, then they are supplementary. That is a true statement. Remember, linear angles form a line, so they measure 180 degrees, and that's the definition of supplementary. Our converse then is if two angles are supplementary, then they are linear. So now we're going to kind of think about that. Is that true or false? Hopefully everybody come up with that this is actually false, because there could be two non-adjacent angles that would make those that would measure 180 degrees, make them supplementary, but they don't form a line. And number two is if two angles are supplementary to the same angle, then they are congruent. That is true, because they're both going to have the same measurement. They have to be supplementary to the same angle, so they're both going to have the same measurement, so they're going to be congruent. Our converse is if two angles are congruent, then they are supplementary to the same angle. Again, when we think about that, if they're congruent, they're going to have the same measurement, so they're going to be supplementary to the same angle. So that one's true as well. The last one, if 3 points are collinear, then they are coplanar. We learned beginning of the unit that if 3 points if a line is in a plane, then all the points in that line are in that plane, so they would be coplanar. Remember, we do know that they're actually on multiple planes. So this is going to be true. And then our converse is if 3 points are coplanar, then they are collinear. Here we have to kind of think that one through, and remember we learned that to have a plane we need to have three non-collinear points, and where they're already talking about the 3 points are coplanar, then there's already a plane that exists somewhere. So they don't necessarily have to be collinear. So that's going to be false. Okay, so that's that. So now we're going to move on. We're going to do a review of two-column proofs with the linear relationships. So here we have a given and a couple of on a picture. Take a few minutes, kind of work through the two-column proof here. I've provided you with a box with the number of lines you need to prove this is true. So you have kind of a framework of what you're looking to do. And then just remember that you should be filling in every box, because every box will need a step, because that's what the proof is. So take a few minutes to do that, and then we'll come back and go over it when you finish. Okay, so here's our answer when you've kind of gone through. We had all our given statements. We can put all the given statements in this one in the first box, because they're all pretty much related, and we really need to get them. We really need to kind of have them there before we can even do anything. Our next statement then is going to be AB equals DF, the measures of AB equals the measure of DF, because that's our definition of congruent statements, where we were told that AB was congruent, our line segment AB was congruent to segment DE. We're able to say that their measures are congruent. Then our next step, again, 2 points, 2 lines, 2 pieces of information on the same line because they are related. We have AB equals BC, and then DE equals EF, because that is the definition of a midpoint. Our line segment AC is broken up into 2 parts, AB and BC, with BB in the midpoint, so they have to be equal. So we're able to kind of throw in there the definition of a midpoint there. So then our next line, we're going from the AB to equals DE. We're plugging BC there in for AB, so we get BC equals DE. That's our substitution property, because AB equals BC, so we can plug BC in wherever we see AB going forward. Similarly, the next line, BC equals EF. Now we're doing the substitution property, substituting EF in for DE. So now we have that BC equals EF. So then our next step is the last step. We can say that line segment BC is congruent to line segment EF because of the definition of congruent segments. If 2 segments have the same measurement, then they're congruent. Hope that makes sense. I hope that was a fairly straightforward one. We kind of worked on that a lot last week on Friday. So hopefully that kind of made sense as you were going through it. Again, try to mark up your picture with everything you know. I didn't do that on this example. But then once you're kind of seeing what's happening and what you're trying to prove, we always know too that you can fill in the BC, line segment BC is congruent to line segment EF in that last box, because that's the last box you're trying to prove. So if you kind of maybe needed to work backwards to it, that would work too. But definitely kind of try to see what we have given and work through there. Everybody make sense? Everybody understand that? Because like I say, it's the line segment relationships are something we're going to need to know, but we just really need to kind of have our head wrapped around the thought process and the flow of going from the givens to the end on all these 2-column proofs. Okay, let's start with angle relationships. We've got 2 angle postulates. Just like we had the ruler postulate in line segments, we have the protractor postulate for angles. Given any measure, the measure can be put into a one-to-one correspondence with real numbers between 0 and 180 degrees. So basically, you can measure an angle with a protractor. Again, it's not something we're going to focus on a lot as we go forward in this. So the important one, though, is the angle addition postulate, which is similar to the segment addition postulate. Means that point D is in the interior of angle ABC if and only if the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So I've drawn a picture. We have our angle A. It's broken up into 2 points, 2 other smaller angles, divided by the vector that goes through point D and point A. So we can say angle D is in the middle of that angle ABC there. I just didn't put the points in, but just assume that's angle ABC. So we're saying that the measure of angle 1 or angle ABD is going to equal the measure of angle 2 or angle DBC. So that means that it is definitely in the interior. So it's something we're always going to know is we can add those 2 angles together to get the measure of the big one. Okay, so there we go with that to help you out kind of with what that's trying to say. Angle theorems. We have some more theorems we need to talk about too. Again, this is stuff that we've kind of already learned when you're kind of looking at the names of these, supplement theorem and complement theorem. I think you've already kind of figured out what we're going with when we go through them. The supplement theorem states if 2 angles form a linear pair, then they are supplementary angles. Notice we're talking about linear pairs here, so we want to start with that. But we know that if angle 1 and angle 2 form a linear pair, which we see in our picture that they do, then angle 1 plus angle 2 has to equal 180 degrees. It's going to come in very handy as we're trying to do a lot of these proofs. And then the complement proof again, if the non-common side of 2 adjacent angles forms a right angle, then the angles are complementary angles. So again, we're told if line GF is perpendicular to line GH, then angles 3 and angle 4 are going to equal 90 degrees. And we're shown that the big angle FGH was 90 degrees because it had the 90-degree box. So now we're able to say that those two angles do add up to 90 degrees. Does that make sense? Okay. Here I want you to work through using those two measurements, the two theorems that we just learned, or we just kind of had reinforced. I want you to work through these two geometry/algebra problems to find the measurements of all the different angles. And then I want you to enter those answers into Edpuzzle. Okay, so if we work through this, we kind of see that the first one is angle 7 and angle 8 form a linear pair. So we're going to be able to add angle 7 to angle 8. So when we kind of do that and work through our algebra, this is the algebra for it. You should have ended up with x equaling 30. And then angle 7 should have been 155 degrees, and angle 8 should have been 25 degrees. Same thing on the second one. We see that all those angles form a linear pair, so we should be able to add them all together and solve all our math through. So that's a lot of stuff we're adding together. We get down to x equaling 6. So then we find out that angles 5 and 6 are 30 degrees each, and angles 7 and 8 are 60 degrees. Again, I think I mentioned it with the line segment stuff on Friday. Don't ever assume that your pictures are drawn to scale. They'll be as close as they can be, but sometimes you'll draw a picture, or the picture you're given, or even the picture that you draw might not work out to what we're expecting the answer to be once we kind of solve through it. So don't worry about that. Just kind of use the picture as a guide of what are we looking at, what are they trying to tell us. Okay? All right, so some more stuff. So just like our line segments, there are similar properties to the congruence of angles. We have our reflexive property of congruence, where angle 1 is going to equal angle 1. Or angle 1 is going to be congruent to angle 1, sorry. Then we have the symmetric property. If angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. We're able to flip it around and say that they're still congruent. And then again, the transitive property, we learned this again last week on Friday. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then we can say angle 1 is congruent to angle 2. This goes back to the standard basic logic puzzle or logic statement. If A equals B and B equals C, then A equals C. Does that make sense? We're going to use these a lot as we go through a lot of our proofs. So just we want to make sure we understand all this. Okay, there's also some more theorems. We have our congruent supplement theorem, which states that angles that are supplementary to the same angle or congruent angles or two congruent angles are congruent. This was what we had in our one more problem. So if there's an angle that's one angle that has two supplementary angles to it, those two supplementary angles are congruent. Same thing again, if two angles are complementary, then if angles are complementary to the same angle or to congruent angles again, then those two angles are going to be congruent. The vertical angle theorem is a new theorem we're going to talk about. If two angles are vertical angles, then they are congruent. Remember, when we have two lines that cross, they form a group of four angles. The angles that are kind of opposite each other, they share the same vertex, but they don't share any sides, are the vertical angles. They're always going to be congruent. Theorem 2.9 tells us, and all these really have to do with perpendicular angles, or perpendicular angles and right angles. Angle 2.9, or theorem 2.9, sorry, is perpendicular lines intersect to form four right angles. We had talked about that before. Theorem 2.10, all right angles are congruent. Right angle is a specific angle. It measures 90 degrees, so all 90-degree angles are congruent. Again, based on that, our perpendicular lines form congruent adjacent angles. So when you think of perpendicular lines, adjacent angles are angles that share a common side. So those two angles are actually going to form a linear pair, which are the last two theorems. So they're always going to be congruent. 2.12, if two angles are congruent and supplementary, then each angle is a right angle. I think that one makes sense. And the last one, if two congruent angles form a linear pair, then they are right angles. Remember, linear pairs have to add up to 180 degrees. If the two angles that form the linear pair are congruent, they have to have equal measurements. Then they only can be 90-degree angles. Does all that make sense? Okay. Next, we have an example here. We're going to kind of work through this one together. Want to see if you guys can kind of figure it out. Take a few minutes to kind of figure it out here. The video is going to pause, but then I just want you to enter in what you think the line G is in their statements, and then we'll move on from there. Okay, so angle 1, they tell us that segment AB and BC are congruent. That's a given. So from there, we are able to say that angle ABC is a right angle. Remember, the definition of perpendicular. Two line segments are lines that cross to form, or that are perpendicular, form right angles. Line C tells us that ABC, the measure of ABC is 90 degrees. Again, that's the definition of a right angle. We're then told that the measure of angle ABC is going to equal measure of angle 1 plus the measure of angle 2. That's the angle addition postulate. It's the same thing as the segment addition postulate. So then we're going to substitute in 90 degrees for ABC. So now we know 90 degrees is going to equal the measurements of angle 1 or angle 2. So that tells us then that angle 1 and angle 2 are complementary, which again is the definition of complementary angles. From there, we have a given, was angles 1 and angle 3 are complementary. That was the other given statement. And then from there, we're going to be able to say that angle 2 is congruent to angle 3 because of the angles complementary to the same angle are congruent theorem, or postulate, I think it was. So I hope that makes sense. Just a quick short, well, not short, it's actually 20 minutes. Again, but kind of going through that. Like I say, tomorrow we're definitely going to dig into doing a lot more angle proofs. I just wanted to kind of show you, get you back into the swing of it on the Monday. And I hope everybody understands that. Definitely kind of work on coming up with a way to keep all of your postulates and all of your theorems kind of in order and organized, and how they all kind of group together. I'm still trying to think of a way best for that for my side as well. And as soon as I get that, hopefully if you, like I say too, if you guys come up with something you think is a really good idea, let me know and we can share it with the class. So again, I hope everybody has a good day. We're not going to do any homework tonight because I don't want to get into a lot of the angle proofs yet because you haven't seen a ton of them. So free night for homework, and I will talk to everyone tomorrow.